So the quadratic formula is going to enable you guys to solve any quadratic equation, right, with basically just one step. Now it's not really going to look exactly like one step, but essentially what happened is some guy or some woman or some person at some point got really tired of completing the square. They were like, I'm doing these steps over and over. It's really easy to make a mistake if I just forget one little part of this procedure. So I'm going to do it once and for all. I'm going to take this equation, ax squared plus bx plus c equals 0. And I'm going to solve this by completing the square. And this was like the brilliant genius moment that led to the quadratic formula. Okay. So completing the square can solve any quadratic that can be solved. This can represent any quadratic. So when we combine the two, we'll get a solution for every quadratic ever. And it will be a formula. So, how do we complete the square? The first step is to do what? Yeah, we have to divide every term by a. I'm going to divide by a. And I'm going to write the steps over here. What if a were negative? Will that affect this? Right now I'm just saying positive a, aren't I? If I had like negative 2x squared. Would I? Get rid of the negative 2. That's exactly what I'm asking you. Would you have to divide by negative a if sometimes? Or is it always just dividing by a? Because if we have something like negative 2x squared plus whatever x plus whatever, you know, don't we have to divide by negative 2?
Would you just divide by 2 and then it would be negative?
What is a here?
Negative 2.
A is negative 2. What is negative 2 divided by negative 2? Positive 1, right? So even if a is negative, I'm still just dividing by a. But a could be a negative number. Even though it doesn't really look like it here, it looks like there's no negative there, it just looks like a. Right? But a could totally be negative, 3.725. A could be anything. And it would still cancel out. A over a is still going to be just 1, except if it were what? When will this not work? Yeah, if a were 0, 0 divided by 0, we can't divide by 0. So will this really work for every quadratic ever? It will, because think about it. If a is 0, then it's not a quadratic. We have 0x squared, so that makes it not a quadratic. Right? So this will literally work for every single thing that is a quadratic. It won't work if a is 0, but if a is 0, this becomes just a linear equation. All right. So a divided by a, we've agreed, is just going to be 1 for everything that's possibly a quadratic. So we have x squared plus, and I'm just going to write it like this, b divided by a, x, plus c divided by a equals, and 0 divided by a is still just 0. What is the next step in completing the square? Yeah, so we need to subtract our constant. And our constant here is c over a. We have x squared plus b over ax. And I'm going to leave a blank there, just like we do with completing a square, equals negative c over a. Okay. What do I need to add to both sides? What's my completing the square? How do I complete the square? We look at this term here. So we have b over a. What is half of b over a? B over a times a half, that would be b over 2a. Right?
No, it's negative b.
Yeah, so isn't that kind of interesting? That's kind of where the x coordinate of the vertex comes in, at negative b over 2a. Which is kind of interesting. It's not just a coincidence. Then we're going to square this. So b over 2a squared is going to give us b squared over 2a squared, which is 4a squared. Because we have to square the whole thing. I have to square the 2 and square the a. So that's what we're going to add to both sides. Now I'm also going to remember that the b over 2a is what my perfect square will be. So adding b squared over 4a squared and adding it over here. Okay. All right. Now what? We know that this whole side is equal to what?
0. No.
We're going to factor it. X plus what?
B over 2a.
Yeah, x plus b over 2a squared. So this equals this. And we could FOIL it and prove it to ourselves. X times x would give us the x squared. X times b over 2a plus another x times b over 2a would give us just b over 1ax, right? Because we're combining the two halves of it. And then this squared, we get b squared over 2a squared, which is 4a squared. Right, 2a in parentheses squared. So this equals this. You can prove it to yourself if you want to. Write out the FOILing. And then on this side, we want to create a common denominator. And I'm going to write the positive term first here. So I'm going to write b squared, and then I'm going to create a denominator of 4a squared for both terms. So what is missing here to create the denominator 4a squared? What do I need to multiply this by? 4a. You guys see that a times 4a is going to give us 4a squared? So then I also have to multiply the top. I can't just change just the denominator. So now I have negative, and I'm going to put this in the typical order that we put variables in. Number and then alphabetical order. So I'd have negative 4ac over 4a squared. And now I can combine this fraction with this fraction because I have the same denominator. So this is b squared minus 4ac. So what I did in this step, I forgot to write this step. So in this step we add the completed square to both sides. So we did up there. And then down here we factored and we combined our fractions. Right, so this is the step that is completing the square. We're figuring out what we need to add to both sides. Alright, let's rewrite that up here. So we've got x plus b over 2a squared equals b squared minus 4ac over 4ac. I mean 4a squared.
Is it supposed to be underneath the a squared? Up there.
Oh no, this I'm just leaving that because that's what we started with. So just copying what we had, I'll just erase that. Copying what we had up top. And what is the next step of completing the square? What is the next thing that we have to do?
Square root.
Take the square root of both sides. Okay. The square root of a square is just whatever we started with, which is x plus b over 2a. And that's going to equal, here I'm going to split the square root up. The square root of b squared minus 4ac. Can I pull out the b squared from the square root? Right, I can only pull out factors. So I can't pull out the b squared as a b because it's not b squared times 4ac, it's b squared minus 4ac. Okay. And then the square root of 4a squared, which is just going to be, let's rewrite this, x plus b over 2a equals nothing we can do with this. But this just simplifies to the square root of 4 is 2, and the square root of a squared is a. Well, there's one really cool thing happening here already, which is what? What do you notice? Yeah, look at the denominators. They're the same. That's great. Because now we're trying to isolate x here. So we subtract b over 2a. So again, now this step we're isolating x. Okay, I forgot one thing though when I did this, which is this, the square root on this side, we always remember to put what in front of it? Yeah, plus or minus. I'm going to choose to just put it in the numerator. Right? It doesn't matter if I put it out front, in the numerator, in the denominator. It's a fraction, right? So if the numerator is negative and the denominator is positive, then the whole fraction is negative. So I can just apply that to the numerator. And I want to do that because I want to keep my denominators the same. I want to keep that 2a down there. So over here I just have x. Over here I'm going to write the minus b over 2a first. So I have minus b over 2a. And then I have plus, and then I have the plus or minus square root of b squared minus 4ac over 2a. Now I can combine these two fractions because I have the same denominator. So x equals negative b plus or minus the square root of b squared minus 4ac over 2a. And believe it or not, we're done. This is the quadratic formula. Now you never have to do completing the square root, unless someone asks you to on some sort of a weird test or something. Okay, how does this work? What does this look like? Why do we care about the quadratic formula? So this is something you're going to want to memorize. There's not a lot of formulas in algebra that we ask you to memorize, really. I mean, in the first half, we asked you to memorize like the linear equation. But here's the quadratic formula. X equals negative b plus or minus square root b squared minus 4ac over 2a. Okay, let's say it together. I'll say it once, and then we're all going to say it together, like a big, beautiful chorus. All right, x equals negative b plus or minus the square root of b squared minus 4ac over 2a. Ready? X equals negative b plus or minus the square root of b squared minus 4ac over 2a. That is it. So, let's say I gave you a problem like the one we started with today, which was 2 as a warm-up. 2x squared plus 3x plus 1 equals 0. Or it could say equals y. If it says y, the instruction will be find the zeros. If it says equals 0, the instruction will just be solve for x. The way we do this, let's first identify a, b, and c. So what is a in this equation? 2. What is b? 3. And what is c? 1. Right? Now we take those and we plug them into this equation. X equals negative b, which is negative 3, plus or minus the square root, and you can do some of this as you go. So b squared is 3 squared, so that's 9, minus 4 times a, and a is 2, and then c is 1, so that's not going to affect my math in the end, over 2 times a, and a is 2. And I'm done, but now I just have to simplify that. So I have x equals negative 3 plus or minus. In my square root, I can't take the square root until I combine these two terms. So I'm going to have 9 minus 8. And then 2 times 2 is 4. X equals negative 3 plus or minus the square root of 9 minus 8 is 1 over 4. Sometimes you'll have to stop right here. Because if you have a square root that's not a perfect square, so if I had like a 5 here, that's as simple as I'm going to get this, this solution. But in this case, I don't have to stop because the square root of 1 is 1. So I have x equals negative 3 plus or minus 1 over 4. X equals negative 3 plus 1 over 4 is negative 2 over 4. Or negative 3 minus 1 is negative 4 over 4. So simplifying that, negative 2 over 4 is just negative 1 over 2. And the negative 4 over 4 is just negative 1. And I think that's a little easier than completing a square. What do you guys think? Seems a little simpler. You don't have to take like the square of a half of b. Right? Although technically you did do that, it was just in this formula. Okay, let's do some practice. I'm going to turn this guy off.